Hi, we're back to question 4. So with question 4, this is an 11 marks question. That is 10% of the entire paper. This question 4 is actually really easy. It's on atomic structure and calculating isotopes. So let's dive into it, okay? So with question 1, there's a little bit of memorizing, I must say. Okay, after a while you just get the hang of that. Okay, but let's go to the basic on how to conquer this now. First, we have got 3 subatomic particles in an atom. So if you're looking into an atom, there are these 3 things inside it. So neutron, proton, and electrons. What is essentially inside is our neutron and proton because they are found in the nucleus, which is like the core. So if I have an atom over here, your neutron and your proton will be right in the middle. And what's outside floating around what we call shells, those are your electrons. Okay, so electrons are on the outside. Okay, so depending on how many shells there are, you will have different number of electrons. Okay, so that's the location. That's the location of the 3 atomic particles. What is this question essentially testing is they are testing you on the relative mass. Now, out of these 3, there's only 2 of them that has substantial weight. The word relative here is in comparison to, it's like a ratio. If you think about it, it's like a ratio. Yeah. Okay. So when compared to one another, what is their masses? So neutron and proton, they have relative masses of 1. That basically means the mass of neutron and proton is equivalent. They are the same. But electron, on the other hand, is really, really tiny. So it has a really tiny mass compared to proton and neutron. So the number that we use to remember for electron is 1/1840. If this is really, really hard, they accept alternative answer like this, 0.0005. The only challenge that I can foresee here is students miss out the number of zeros. Okay, they also allow 0.006, or like 1800 or 1/2000. Okay, this is the first time I do see this potential answer as accepted. Okay, maybe there's a change in exam board or like the exam personnel in there. Okay, but if you are writing out these 2 alternative answers, which is acceptable this year, then take note of the number of zeros. Okay, I think that's the biggest possible point of careless mistake. Okay, let's move on to B. For B, we are given lots of information here. Okay, when you are dealing with information like this, you can do something for yourself. Okay, so we have got species A to F. You don't need to go to the periodic table and try to identify, oh, proton 13, it will be aluminium. Okay, don't assume that. Okay, so that's the big no-no that you should not do. But rather what you can do for yourself here is, when you see that number of proton and electron is the same, it will mean that A, specimen A, is an atom. It exists in the atom. That basically means there is no charge. Okay, so same thing, you can go down this table. B, species B has 1 proton and 1 electron. That also means it's an atom as well. So it's F, 18 proton and 18 electrons, so that's an atom. But what happens then if you have things like C? Your number of proton is less than the number of electron. Now with every proton, that just now we mentioned, okay, if there is 9 proton, then the charge over here will be positive 9. And if there's 10 electron, because every electron has a charge of negative 1. Oh, I've got to talk about this. This is the, right? Proton has a charge of positive 1, electron has a charge of negative 1. Neutron, as its name suggests, it's neutral. So there is actually no charge or 0 charge for neutron. Okay, so back to C again. If you have got 9 proton and 10 electron, what's the overall charge of this species? It is a negative 1, and that will make it an ion, because ion is a charged particle. Okay, charged particle, and an ion can be either positively charged or negatively charged. If it's positively charged, it's known as a cation. If it's negatively charged, it is known as an anion. Okay, so that's basically how we identify whether it's an ion or an atom. You can do the same for D. 7, so it's plus 7, and then 10 electron again, it's minus 10. So the overall charge is a negative 3. So same as E, whereby now we have more proton, 2 more proton than electrons, so it becomes a positive ion. Okay, so with that understanding, we're going to go into the question here. Right, so give the letter of species that has 3 electrons in the outer shell. And how do we do that? Okay, so we are going to look into the number of electrons. Okay, and A would be the answer because based on the number of electrons, there are 13, right? So 13 electrons, and if you were to arrange electrons, this 13 electron, the first shell, let's just do a quick recap here. Okay, so the first shell can hold a maximum of 2. And then second or third shell can hold a maximum of 8. So you always have to fill the inner shell first before you fill the next shell. So first shell can hold 2, so you move on to the next shell can hold 8. That will only give you 10 electrons so far, isn't it? Okay, so the extra 3 will move into the third shell. That means A would be a species that has 3 electrons in the outer shell. Okay, so another word for outer shell is valence. Okay, valence shell. That also means outer. Okay, right. So we have part 2 here. Give the letter of a species that is an ion with a 3 negative charge. Now, if you have understood the earlier part of my explanation, you will be able to quickly identify that D is the answer. Okay, because it has 3 more electrons than proton, and since every electron is negatively charged, we've got 3 extra ones. Then D would be the ion with 3 minus charge. Okay, right. Next one. Give the letter of the species with a mass number of 19. Now, how do you calculate mass number? Is when you add the total number of proton and neutron. So let's quickly go back to the table and see why is C the answer. I'm going to highlight the C in red. Okay, you will see that C has 9 proton and 10. We are not looking at electrons. For mass number, we are only looking at adding proton and neutron, so mass number. Okay, so if you quickly add up A, the mass number is 13 plus 14, that's 27. B will only be a mass of 1. Let's take away all this. Okay, and mass number of C will be 19, which is basically our answer. D is 7 plus 7, that's 14, so on and so forth. Okay, so mass number again is the addition of proton and neutron both together. So the answer would be C. Okay, so far so good. Hopefully this is not too fast. Okay, then we move on to isotopes. Okay, so we've got 2 isotopes here. We have got lithium. They're both lithium, but the number at the top is different. One is 6 and one is 7. So what makes them different? All right. So this is a really popular question they are asking for. 1 similarity and 1 differences between the isotopes. Now when it comes to differences, you can see the number at the top is different. But what is the number at the top representing? The number at the top is actually representing our mass number. Okay, and so most students or some students, not most students, I say some students, they will just go, oh, the difference is the mass number. This is really risky because you might not get your full mark here. Okay, you need to break down and understand what exactly is contributing to the difference in mass number. Okay, now before I go into that, I just want to take a moment to ask you to look at your periodic table. You will see that your periodic table would provide lithium with a 3 at the bottom or either at the top, depending. This 3 is actually our proton number. Okay, so if you could recall, mass number is proton plus neutron. Okay, and since the proton number is the same, right, the similarity here is both of them have 3 proton. Then what is the thing that's making the mass number different is actually the number of neutrons. So if you think about it, the number of neutron for lithium 6 is only 3 neutron, and then for lithium 7 there are 4 neutrons. So the main difference in the isotopes is the difference number of neutron. Okay, and that results in the difference in mass number. So take note. In order for you to get 2 marks, you need to specify that they have the same number of proton, which is 3. They have different number of neutron. Unfortunately, if you mention the difference is number of mass number, you will only get a maximum of 1 mark here. Okay, so careful, take note of that. Okay, so this is the main idea of doing this iGCSE walkthrough. Really is to highlight what are the common mistakes that students are making, and you, when you're watching this, hopefully this is impactful and helpful. You would actually take note of all these small errors the students are making, and you don't make them yourself when it comes to your test or your actual iGCSE. Okay, right. Final question, 3 marks question, not difficult, but a little bit tedious. Taking away all of this, so it will not disturb your visual. Okay. So we have a magnesium that contains 79% of magnesium 24. Okay, I'm going to highlight in different colors. 10% magnesium 25, and then 11% magnesium 26. Okay, so we've got magnesium 24, 25, and 26, like 3 different magnesium over there. Okay, and oh wow, very nicely, I've kind of do my working steps quite similar. So for magnesium 26, that's 11%. You just multiply it together like this. Okay, and do the same for magnesium 10. So 10 multiplied by a mass of 25, and then you've got 79% that has a mass of 24. This step alone will actually get you your 1 mark, okay, because you understand how to use the percentage abundance. This is what we call percentage abundance, by the way. Percentage abundance. Basically, what's the percentage of the different isotopes in the atmosphere, okay? And then you divide everything by 100. Now why? Because all of these are given in percentages, okay? So you need to divide by 100. Then you will get your, if you are careful enough and put it in your calculator, you will get an answer like this, okay? That is your 2nd mark, because you get your answers. And the 3rd mark here that some students tend to miss out is this statement here. You do need to give your answers to 1 decimal point. Now these are small things, but they do actually add up to quite a lot of carelessness in marks or loss in marks, because you were rushing through your question, you didn't see the instruction, the command words, okay? So give your answer to 1 DP, you need to present your answer as 24.3. If you give your answer to here, you only get a score maximum of 2 out of 3 marks, so do take note, okay? So this is not a very difficult question, it is easy to do, just a little bit tedious, and you just need to take note of the instructional words that comes along, or what we call command words in iGCSE. At iChem Achieve, it is not just about passing. I'm hoping that you appreciate chemistry, you understand chemistry at a deeper level, and you enjoy learning chemistry in this process. So if this video is helpful, please like and subscribe, and I will see you in question 5, and I hope you will join me for this entire video series of 2025 paper 1.